Hi, my name is Ori. I was the CEO and co-founder of Upsolver. It was recently acquired by Qlik. Today I lead the Upsolver group within Qlik. Today we came to talk to you about the Lakehouse, the Iceberg Lakehouse. I see that you have a lot of questions, which is great. Always the best way to convey material like that. And I want to start by talking about the demand for Iceberg. Like, I've been talking to customers building data lakes and data warehouses for quite a few years, and we are definitely seeing a wave, not a small wave, happening with the Iceberg. If we look at the history of data warehouses, we used to have the transition to the cloud where everyone were running to buy something like an Amazon Redshift instead of managing their own instance. And then everyone went to a decoupled data warehouse and forgot about the old managed cloud data warehouse. And then they're moving to a decoupled storage layer, which is basically what we are doing with Iceberg. And it's not a small transition. The reason I'm mentioning all of them together is that we are seeing everyone run into Iceberg, and that statistics kind of backs this up. This is actually data from last year, from a survey that Dremio did among enterprises. And among enterprises, 69% think that more than 50% of their analytics will run on Iceberg within 3 years. That's quite a change. I think maybe even a little aggressive. Migrations always take longer than you plan, but definitely that's where they're aiming for. So why? What's the reason? Why are everyone rushing to Iceberg like it's the new gold? And I think that there are eventually two key reasons. One is cost, and the other is no locking or interoperability, depending how you want to define it. With cost, every time that you use a data warehouse, and we as a data integration company know that, you write into a data warehouse, you pay money for the data warehouse. There is a cluster running that spins up. By the way, as a company that's doing a lot of CDC, we often see those costs really pile up because you want to get your data in real time, and the cost of merges into data warehouses are something that's very expensive. And now there is a paradigm shift. Instead of paying the data warehouse when you're ingesting, I can just write to S3. I don't need to pay to anyone. I can take an entire piece of cost that's very material in the data warehouse bill and just eliminate it. And it's very easy for someone that owns a data warehouse in an enterprise to understand that. It's not, hey, I'm going to reduce costs, some kind of amorphic promise that people don't understand. I'm shutting this down. That cluster does not exist anymore. Very easy to understand the cost benefit. And that's without going into philosophy of there is more let's say, negotiation power with the data warehouse vendor, just talking about the cost that you shut down. And that takes us, I think, to the second reason, and I don't think it's less important than the first reason, and the interoperability. And the reason that's so important for everyone right now is AI. Maybe I would meet you a few years ago and I would say, well, you're not going to have just one data platform for all your data. And people would argue, no, one-stop shop is great. People forgot the lesson from their Oracle days that it's very hard to be tied into one technology. I was an Oracle DBA. I remember using a lot of Oracle tech that I don't necessarily saw as best of breed because my data was there. You're first going to try a tool that's going to be close to where your data gravity is, where your storage is. And Iceberg basically unlocks us from that. So if tomorrow I want to use Databricks for AI and Snowflake for BI, which is something that we see all the time, I can do that with the same copy of data. I can choose best of breed without the burden of my legacy and being tied to a specific format. I think those together are the two main reasons that are pushing people to Iceberg. And kind of, if you're not convinced, it's easy to just look at what happened in the last year or so. Every big data platform vendor has made a big play around Iceberg, and if you're going to listen to their earnings call, they're going to talk about Iceberg as one of their key initiatives. So that's including Snowflake, but that includes also Databricks that made a big acquisition and went into that market and didn't want to let the Iceberg revolution pass them, although they had data lake. And you can see it in Amazon that are releasing Iceberg products left and right. Like every one of the major data platform companies or cloud providers are standardizing on Iceberg as their first priority format, and you can say that for some, maybe the second, but for most, it's just the first. So the entire market accepted this as the standard of how we are going to build the lakehouse, which is great. I founded Upsolver many years ago. I've been waiting for maybe 4 or 5 years for something like this to happen, but it's great that it's finally here. All right, so what is actually a lakehouse? I think the easiest way to understand a lakehouse is it's just a decoupled database. You take all of those things that you see here on the screen, used to be just one box in my organization, and now we're separating all of them into separate pieces. The piece I think that's hardest for customers to actually get right is storage. You can say that's underneath the storage layer, you could include the files that you store, the metadata that you store using Iceberg, and maybe even the catalog itself. All of these are now I can buy this from here and this from here, and it's all very confusing for the customer. And the second thing, it's also harder because the IP of optimizing a file system for good performance is something that database companies have been doing for quite a while, and that's really their core IP. And now you're going to say, Mr. and Mrs. Customer, you're now responsible. And if you're not going to store your data in the right way, you're not going to get the same performance you got in your data warehouse. And that's a recipe for failing. And why am I saying it's a recipe for failing? Because we already tried it. There was Hadoop. Hadoop started with the promise of replacing the data warehouse. Why didn't it fail? Why did it fail? Because it sucked. It was slow and hard to use. Like eventually, users want the same thing that they had with the data warehouse. They want the cost advantage of the lake, but they want the ease of use and the performance of the warehouse. That's what's actually making it into a lakehouse. So now, how will a customer do this, all of this? And the second question, which vendors are going to help? Because in the past, no one can really touch what was most precious for the data warehouse company. But now, if I'm a customer, I'm thinking, well, if my problem is that I'm going to be locked to a specific data warehouse, should I let the data warehouse now govern all of this open source thing? Won't I find myself in the same place I've been? Like I'm doing a project for the same thing I'm trying to solve. So what will I actually do? I can actually go to a data integration company that lives off the idea that there are going to be multiple data platforms that has every incentive to create a data layer that all the different data platforms could be reading from. So now it's not only a question of how I build a warehouse in a different way, but who am I going to build this with? And now I also have the option, we have to talk about it, the customer can decide, I can do this myself. For some customers, that's fine. That's they welcome the engineering complexity. All right, so just repeating a little bit of the complexity, optimizing and tuning file systems, very hard work. I've been doing this for quite a few years, very hard work to do. Cleanup, something that sounds very intuitive. People may remember this from the days that you used to run vacuums on data warehouses, and data engineering teams used to complain a lot about those maintenance tasks that they need to do. So think about it, that every time I'm going to go to Iceberg and I'm going to perform a commit operation, I'm going to create an old snapshot. I'm going to create orphan files. All of this is going to create a lot of garbage. That garbage is going to slow down my performance, and it's going to cost me more in storage. So I need to clean all of that in a good way. I need to suddenly integrate with multiple catalogs because I want to run the data in one place, and I want Snowflake and Databricks and Amazon and like everyone to be able to read it. But there are differences between the catalogs. So I can, for example, write data in a way that Amazon can read it and Snowflake will not be able to read it. True story that influenced the way we are going to release Lakehouse on the Qlik Cloud. The last one that I want to talk about maybe in a second, I know we don't have a lot of time, merge operations. That's one of the big ones. We see it a lot as a company that's doing CDC. Merge operations were very expensive on the data warehouse. On Iceberg, I would say we are still in the early days of doing merge operations in real time and in high scale. And you need to engineer your way around it if that's what you want to do. That's something that we've been spending quite a few months on at Qlik. All right, so January, Qlik acquires Upsolver in order to go deeper into the lakehouse. So I wanted to maybe give you some visibility why Qlik decided to do it. And I think maybe a good start was experience. So Upsolver has been building what you can compare to Iceberg. So data lake tables. Upsolver was the combination of ETL with data lakes. I want to stream high-scale data into a data lake and query it in the same level of performance I had in my data warehouse. Since 2017, we were kind of beating our head around how are you going to build a file system that's going to perform well over object storage. I think that's before Iceberg even started. When Iceberg came out, it was the standard we've been waiting for, and we of course adapted all our product into for Iceberg. The second reason was high throughput. So Qlik is a company that works with big data, but AppSolver was a company that worked with really big data. So if Qlik would work at the scale of tens of thousands of events per second, AppSolver worked with millions of events per second and added new sources into the Qlik ecosystem. For example, streaming and object stores with data at very high scale that would be processed in the cloud in a cloud-native way. So you can basically scale with the cloud for as many events per second or whatever workload we wanna support. So that's something that was important for Qlik. So one story was the lakehouse. How is Qlik going to come into the lakehouse and have a best of breed product? And the second, how are we going to process very big data and support streaming workloads, which is what AppSolver did. All right, so with this slide, I'll try to sum up the offering that we used to have on AppSolver product, not the Qlik product yet. We're going to talk about the Qlik product a little later, but on the AppSolver product, you can divide it into three sub-services that were used and are going to be reintroduced into the Qlik platform. The first is ingestion. I'm going to choose a source, and now I want that source to be an Iceberg table in my lake. I don't want to start spending a lot of time on scaling and engineering and like all the nitty-gritty stuff. We called it zero ETL because it was really zero ETL. All you defined is your source and your target, and all the rest happened automatically, including schema evolution. So the first, we always have to start with ingest. The second is once that I actually have a table, AppSolver had an entire component just for managing Iceberg tables. By the way, you didn't have to write those tables with AppSolver in order to manage them with AppSolver. So it only that component of AppSolver connected to the Iceberg catalog and to S3, looked at the file system, and there were a bunch of parameters that influence how it works. How many files, what are the size of the files, and what velocity are they writing? Like it's just, you can call it an equation we've been balancing since 2017, and I'll share some results in a couple of minutes, benchmark to other solutions. So ingest, optimize, and the last part was actually doing some transformation, but those transformations are not exactly the same like Qlik transformation. So in Qlik, in QTC, you're able to write a transformation that will be pushed down into your data warehouse. With the Iceberg Live tables, you basically write SQL that's being processed on the AppSolver engine. So the AppSolver engine is a streaming engine, so I can do my data prep with streaming, and then I could be using AppSolver. And after I'm going to finish, I can use pushdown in the same way. So you could compare this to products like Snowflake dynamic tables or Databricks live tables. It's a very similar offering. We've been doing it since 2018, so it's not new to us. The idea, I want to declare more tables in my medallion architecture, bronze, silver, gold, using SQL, and not worry about orchestration and engineering. I just want everything to be declarative. Declarative is the key word. And of course, there's the catalog and whatever query engine you want to put on top. All right, so I promised to share some statistics. So there are two types of statistics on the screen. On the left, you see storage. So I used to have a table that was 10 terabytes, and now I'm going to move to Iceberg, and suddenly that table is going to be 50 terabytes. Not cool. Like, that's not how I want to work. And the closer you get to real time, the more you have commits, the more you're creating old snapshots, creating old files. So managing the storage in a good way means that you need to do it close to real time, and you also need to make sure you're not missing anything. If you check the open source doesn't necessarily always going to let you do this, even if you decide to do it on your own. It took us a while to go from open source level to enterprise level. So on storage, we can say that we actually created the most efficient storage out of those options that were evaluated. So for example, a Snowflake Iceberg table in that benchmark was more than 2x in the amount of storage. And this was actually smaller than a Snowflake native table in Snowflake proprietary storage. That's this year. So this is native Snowflake table. This is Snowflake managed Iceberg. This was a table that was managed by Glue, and a table that's managed by AppSolver. Managed by AppSolver means that Snowflake could still read it, but AppSolver was managing. Snowflake would call this an external table to Snowflake. So that's storage. On the other side, the query performance, where users get a little more sensitive, it's not just costing more money for the organization. We said we want the lakehouse to perform as well as the data warehouse. So we tested it, and I think that what we were most proud of in that benchmark is that we managed to get to a similar performance over Iceberg as Snowflake native storage. I took Snowflake, tried to query Iceberg, tried to query Snowflake native storage, 7% difference. So it managed to actually deliver on the promise, your lakehouse is going to be as fast as your warehouse. And you can see that the difference from all the other solutions was quite big. We ran this, to be fair, towards the end of last year. So we're going to run this again after we're going to release on QTC. The results were very good. All right. Switching to my last slide, these are a few examples of customers and use cases. So there are a lot of tools in data. Sometimes it's helpful you think about what the customer actually did, you understand what the tool is really about. I think the shared thread between all of those tools is you didn't have to be a specialized big data engineer in order to deploy AppSolver. So at Proofpoint, security researchers used it to build a data lake and build software-defined VPN on top. With many different use cases, dozens of different use cases, you didn't have to be a specialized big data engineer. At Unity, maybe a ratio of something like 5 big data engineers to more than 100 developers that took data at a scale of over 50 petabytes a year. So that's almost 15 million events per second.
What does unblocked mean in that?
Unblocked means that there were developers that didn't know or wanted to know Spark in order to prepare data. Data mesh use case in 2018, before it was called data mesh. In ConocoPhillips, the use case was I have an oil pipeline and I want to be able to look at every square foot of that pipeline needs to be monitored in real time, otherwise it can cost you a lot of money. And we were able to deliver that, where the technological challenge was that I need to do a lot of merges into the data lake. That's not a good use case for, let's call it, object storage performance or to data lake tables in general. That's something that we solved over Hive, and today we also solve over Iceberg. I think that I'm repeating the common thread again. You don't have to be an expert in order to do this. This is a simple user experience, but it's going to give you very high scale. AppsFlyer, petabyte scale. Unity, petabyte scale. Doosan, petabyte scale. Cox Automotive, petabyte scale. Repeated examples of petabyte scale use cases were one of the big reasons that Qlik was interested. Yes?
Brief question, just so I understand, because you did talk about storage and optimized query speeds and stuff. Does this mean that an Apache Iceberg table has to be loaded from other sources and then we replace that old source, throw that source away? Or is there like a constant feed, just, you know, like a constant data feed? Oh, we got new data in from this source table. Now we got to go load this Apache table, which increases my storage footprint. Does that make sense?
I'm not sure that I understood. So I used to write into a regular Snowflake table, okay? And now I want to write into an Iceberg table that Snowflake reads from. So what's the difference that you're describing? How is those?
But again, an Apache Iceberg table, right, is another piece of storage that, say, my SQL Server database, right?
Yes.
I still have to load this data into the Apache Iceberg table.
Yes, but I'm assuming that there's going to be, I'm assuming that today you have between 1 and 4 copies, because you have one in your lake, and then you have one in Snowflake, and then you have one in Databricks for your, so I'm going to combine all of this into a single copy.
Okay, got it. Please continue.
I'm actually at my last slide, so before we're going to go next.
My timing's good.
Any questions?
Yeah, I do have a question.
Yes.
So you talk a lot about Apache Iceberg. My understanding that Delta Lake and UDI are like similar to Iceberg, but different. Is that a true statement?
That's a true statement. And I would describe the years between maybe 2020 and 2024 as format wars. So each one of what you just described, the UDI, Delta Lake, and Iceberg, are data lake table formats. And Iceberg came from Netflix, and Delta Lake came from Databricks, and UDI came out of Uber, but went more into open source, and each one had a commercial company behind it. Delta Lake and Iceberg got the most amount of adoption. UDI coming behind, and UDI was a better fit for streaming. I think that's why it got some traction. The main fight was between Databricks with Delta and the rest of the market with the Iceberg. And then suddenly the market converged, and Databricks bought Tabular, which was the company that had the team behind Iceberg. So now that Databricks are saying, instead of having a war, we're going to have both formats and try to consolidate formats and take the best of both worlds for those two formats. So I think that in my opinion, the war is over. Iceberg won. Everyone adopted Iceberg. In the past, Databricks did not adopt Iceberg. Now they adopt Iceberg. Microsoft adopted Iceberg. Those were the companies that were behind Data Lake. Amazon were always around Iceberg. Snowflake are around Iceberg. Google took Iceberg as a first priority. So I would say that the reason we are seeing the customer running to Iceberg is because the wars are over. And now it's clear what's the standard, and you can actually do something and not wait on the fence to see how the market is going to let. I'm not saying Iceberg is better than Delta, or Delta is better than Iceberg. I think the market chose, my opinion. Like, I'm not seeing a lot of customers are saying, hey, maybe I won't choose Iceberg. Maybe it's not the right solution. I'm going to take UDI or something like that. I'm not seeing that anymore, and I've been kind of asking the same questions since maybe 2020. That's my impression and opinion.
Where do you see ClickHouse and Starburst fitting into these kinds of companies?
ClickHouse and Starburst. Well, Starburst is a query engine that also adopted Iceberg at the very early stages, and wherever we are going to write, they're going to be able to read, and they're going to compete with the other providers. I don't want to. I have to say that for me, it doesn't matter who is going to win. And I think the more important is that it's going to be centralized storage, and then the customer doesn't have to commit to one for the next 10 years. That's the first thing. ClickHouse is a little different. ClickHouse has a slightly different use case with proprietary storage. They're adding support for Iceberg, but usually people take ClickHouse for a slightly different use case. So I would, at the moment, exclude that from that and say ClickHouse is less used as a data warehouse, more as a tool that I would use to replace my observability solution, my Elastic, something like that I need to have close to real-time aggregated queries. We use ClickHouse internally, by the way, for what? For AppSolver logs and metrics. We use it. We cannot use AppSolver to process AppSolver for monitoring because we are going to. Who is going to watch over us? Like, we need a different stack for that. So we use ClickHouse and we like it a lot. And it's not a use case that we would do with Snowflake and vice versa.
Very cool. Thank you.
Thank you, Ari. Hello, everyone. Great to be here. I'm Vijay. I'm product marketing lead for for the Data BU, and excited to be here. I know we are towards the fag end of the session today. What I wanted to, so Ari gave you a great overview of the Upsolver platform, the key capabilities, some of the customer use cases, and how, what type of use cases are being powered, right? Now, let's talk about the interesting part. For the last I would say 5 to 6 months, we have been hard at work integrating the Upsolver platform, Qlik. And we have been integrating Upsolver into our marquee data integration cloud platform called Qlik Talend Cloud, right? So we are integrating Upsolver, all the goodness of Upsolver that Ori talked about, that'll be integrated into Qlik Talend Cloud. And today, we are excited to introduce Qlik Open Lakehouse. Qlik Open Lakehouse is a new fully managed capability within Qlik Talend Cloud that enables users to ingest, process, manage, and optimize data for Iceberg-based lakehouses, right? Again, as I said, we are bringing in all the goodness of Upsolver platform into Qlik Talend Cloud. Again, this is not a net new product, it's a net new capability within Qlik Talend Cloud, okay? Not a new product, new capability. Again, we just announced this today at Qlik Connect, and this will be GA, generally available in a couple of months in July, okay? Okay, so before I go deeper into Qlik Open Lakehouse and Iceberg capabilities and what it does for customers, let me take a step back and talk a little bit about Qlik Talend Cloud. I don't know how many of you are already familiar with Qlik Talend Cloud, but I think it's good to just everyone to be on the same page. So Qlik Talend Cloud today offers an end-to-end platform that delivers trusted data throughout your organization for AI as well as analytics, right? It's already been utilized by hundreds of customers, and it has a few key capabilities, right? Number one is ingestion. You can ingest data from a variety of sources, and then you can do either real-time CDC ingestion, you can do batch ingestion, and you can land that data in a variety of target platforms, okay? It's not just ingestion though. You can also do transformations. You can build no-code visual data pipelines, end-to-end data pipelines. You can do basic transformations, you can do advanced transformations, right? You can do push-down SQL transformations and push that down to any platform of your choice, right? So a lot of customers utilize that kind of capabilities. But more importantly, you can also do data quality and governance, right? You can manage data lineage, you can even you can also view trust score for each of the data so that you know if that data is trusted. How can I push that trusted data now into AI models, into AI and for analytics, right? Last but not the least, you can now create data products using Qlik Talend Cloud and push it to a variety of consumption engines, be it analytics engines, be it data science, or be it Gen AI applications, right? So basically, it provides an end-to-end platform that customers are utilizing to power their AI and analytics journeys. Now, I talked about target platforms. It works with a variety of target platforms, including everything from AWS, Snowflake, Databricks. A lot of our customers use Qlik Talend Cloud with Snowflake or Databricks or AWS, Microsoft Azure, and Google Cloud. Now, if you think about it, Iceberg becomes a net new target platform, right? Hey, do I want to push my data into Snowflake, or do I want to push my data into Iceberg now? So as you see here, we are now introducing Qlik Talend Cloud or Qlik Open Lakehouse as an integral part of Qlik Talend Cloud that enables ingestion into Iceberg, optimization of Iceberg, so that you can drive all of this data for analytics and data science use cases, okay? And I'll double click a little bit more on this, but I wanted to give you an overview of Qlik Talend Cloud before we dive deeper into the Iceberg capabilities, okay? Now that we talked about Qlik Talend Cloud, let's talk a little bit more let's double click on Qlik Open Lakehouse, right? The Iceberg capability that we just talked about. So if you're talking about Qlik Open Lakehouse, there are three key things or three key capabilities that we should highlight. Number one is the high throughput ingestion, and Ori kind of mentioned this, alluded to as part of the Upsolver platform. What you can now do is you can now ingest data, real-time data or batch data from hundreds of sources directly into Iceberg tables, into query-ready Iceberg tables on Amazon S3, right? So you can ingest data in a batch fashion or real-time fashion and use that for analytics or for machine learning purposes. That's number one. Number two, adaptive Iceberg optimizer. Ori alluded to this again as part of this is, in my mind, one of the key capabilities and differentiators that Upsolver brings to the table. It's the ability to do always-on optimizations, right? It monitors Iceberg tables, and it determines the optimizations, cleanups, compactions required to minimize the storage footprint and improve query performance. So I think that's the critical piece here, is the adaptive Iceberg optimizer. That's part of Qlik Talend Cloud now. Last but not the least, another critical capability is what I call data warehouse mirroring. Now, what this does is you can now mirror data from your Iceberg tables directly into Snowflake, right? You can mirror this data directly into Snowflake for downstream transformations. By the way, you can do that without duplicating the data or creating another copy of the data, right? So, which means you can now run your ingestion and bronze layer on Iceberg tables, but then mirror the data for silver, gold, and any of the other more curated data sets, right? So those are the three big attributes. But one of the other key things as part of the launch that we are announcing is the integration with catalogs, right? Apache Iceberg catalogs. We will be integrating with 3 key catalogs, including AWS Glue, Apache Polaris, and Snowflake Open Catalog. Now, what does that mean? The moment you are now integrated with these catalogs, what that means is now you are opening up the data to a whole set of query engines, right? You can use Snowflake, you can use Amazon Athena, you can use Spark, Apache Spark, you can use Trino, Presto, Dremio, any engine. So this is the promise and potential that Iceberg brings to table, right? You store data once, but then you can utilize the data across a variety of engines and processing engines and query engines, right? That's the promise of Apache Iceberg, and that's what Qlik Open Lakehouse brings to the table.
Can you specify, you say high throughput, how high throughput?
Yeah, so Ori talked about it a little bit, but some of their customers are bringing in data as much as like 5 to 50 million events per second. So again,
pretty high.
That is pretty high, right? So because they're talking about use cases like cybersecurity, IoT, right, where you're constantly looking at streaming data coming in high volumes, right? Again, now so streaming ingestion is part of it. You can do real-time ingestion from. So it's actually a good question because it's a good segue into my next storyline around ingestion, right? So what you can do with Qlik Open Lakehouse is now you can ingest data from any of these sources. You can do real-time CDC ingestion. You can do batch ingestion from cloud sources, from SaaS applications, from file sources, from any of the operational databases, right? Oracles or any of the MySQL, any of these operational databases. SAP, mainframes. So imagine you now can ingest data from SAP and have it available in S3 tables and then open it up to a variety of query engines and processing engines. It just opens up a world of possibility and opportunities for our customers, right? So now you can bring in data from any of these sources, again, as I mentioned, CDC or batch. But what Qlik Open Lakehouse does is it handles the hard parts very, very easily. For example, it automatically maps source to target data types. It resolves type conflicts, automatically resolves type conflicts. It handles schema evolution and data drift, right? You can easily add or delete rows using this. But the critical aspect here, though, is you can do all of this without the need for a data warehouse. You don't have to burn data warehouse compute for ingestion or for the bronze layer, right? We make it really, really simple, easy, and efficient for customers to bring in data from any of these hundreds of sources into Apache Iceberg in a very seamless and easy fashion, okay? So that's kind of the first attribute that we talked about is around ingestion. And Antoine will talk a little bit more about the roadmap. What do we have coming up today versus what do we have coming up in the future? So a lot more interesting stuff coming up in terms of ingestion in the near future. Okay, so we talked about ingestion. One of the other attributes I talked about earlier, and I think Ori touched upon this, in my mind is the secret sauce from Upsolver really is this adaptive Iceberg optimizer, right? Now think about it. If you're building a lake house, Iceberg-based lake house, you're worried about 2 things. Number one, you want to make sure your storage footprint and costs are minimal, but at the same time, but not at the cost of query performance. You want to make sure you have very comparable, very good query performance as well, right? Low latency query performance as well. Not at the cost of each other. You want to maintain low storage footprint, at the same time, maintain a very, very competitive, very low query performance as well, a very low query latency as well. But think about it. What you don't want to do is have a team of 15 engineers who all they do is sit and tweak and tune every single Iceberg table day in, day out. That's not going to be feasible. That's not going to be scalable. That's the reason why Upsolver builds Qlik Adaptive Iceberg Optimizer, right? And what it does is, it is intelligent. It is always on. You don't have to schedule these optimizations. You don't have to do these optimizations manually. It continuously monitors tables and does optimizations, compactions, cleanups dynamically to make sure you have the lowest storage footprint and a very competitive, very compelling query performance as well. So for example, like the cost-based compactions, it dynamically compacts files based on a number of variables, including number of files, file sizes, frequency of updates of these files, right? So a number of parameters are taken into consideration to do these compactions in a very, very automated fashion. Dynamic partitioning, you don't have to worry about partitioning the data or figuring out, testing and planning out table layout implementations. It does it for you, and it determines the ideal table layout that might work for your data type. Yep.
So on another slide, I saw that these are all workloads, right? These are built-in workloads. Are they customizable, or are these just, do you pick the ones you want to run? Or are these just, it does say always on. So are they always on whether you want them to be on or not? Maybe there's some things you want to you do want to manually tune?
Yeah, so Ori, is there a capability for them to actually pick and choose some of them and then actually manually?
What I said is that every AppSolver or Qlik job is attached to a cluster. So once I shut down that cluster or stop the job, it will stop running, which I can do via UI or programmatically. So the default is always on, which is usually what we do with data integration. You can decide not to. I'm not seeing a lot of use cases for that, by the way. Like usually people just want their data all the time. They want it fresh.
Awesome.
All right. I'll keep that.
And then the last thing is about intelligent cleanups. I think Ori kind of alluded to this. It's about snapshot expiration, right? Deletion of all these orphan files in a very safe and consistent manner. Again, your objective is to minimize the storage footprint, improve query performance, right? So what does all this mean for customers? What does this result in is, one, obviously you get to ingest fresh data, right? From all of these diverse sources, you have access to fresh data within seconds, and you can analyze that in a variety of ways. Obviously, that's important. Number two is because of all these optimizations, cleanups, and compactions, you are now able to reduce the storage footprint and cost by up to 50%. And you saw some of the benchmarks that were shared earlier around storage performance and query performance, right? Storage performance improvement, but not at the cost of query performance. That's what we are aiming for, and that's what customers want, right? So you're talking about query performance comparable to an experience that you can expect from a data warehouse, right? That's what customers can really achieve from Qlik Open Lakehouse. With that, I want to again zoom out a little bit, right? So we were digging into the Open Lakehouse, but keep in mind, this is a part of a bigger platform, the end-to-end Qlik Talend Cloud platform, which allows you to ingest any types of data. You can now transform, data transformations. You can do data governance and quality, right? And Open Lakehouse fits right into Qlik Talend Cloud, where you can ingest data directly into Iceberg tables. You can do compactions. You can do cleanups, and then you can query it using any number of engines, as we talked about, right? And serve that data for analytics, for building data products, or for building GenAI applications. So that's what an end-to-end QTC or Qlik Talend Cloud offers customers. So it becomes an additional compelling reason for customers to adopt QTC, okay? Now, the beauty of all of this is, and again, we are just launching this now, and so Qlik Talend Cloud has 4 pricing additions in terms of pricing and packaging. Everything that we talked about in terms of Qlik Open Lakehouse will be available from standard edition onwards, right? So all of the Iceberg capabilities that we talked about, including ingestion, including optimization, including opening query engines, all of these, data warehouse mirroring, all of that is going to be available starting from the standard edition onwards, upwards. So we are making it really, really easy for customers to get started building their open lakehouses, get started ingesting data into Iceberg, and power some of these very compelling use cases that you saw. Okay, so I think I talked a lot about the capabilities and how this kind of all fits in, but again, a lot of what we talked about now is already launching today, but we have more interesting stuff coming up in the roadmap, right? So what do we have now? What do we have coming up later? I want to call on Antoine, who's going to share a little bit more of the roadmap, but also show you a demo. So more on that pretty soon.
So moving on to this roadmap slide and talking a bit about timelines here. So in May at Connect, we are just launching the Qlik Open Lakehouse, and we are targeting a GA, general availability for July. What will this GA include? So we'll support ingestion from all the Qlik Talend Cloud sources. So that's all the sources that Vijay listed before. So that includes SAP, databases, a lot of SaaS applications, as well as your mainframe system. So all of these capabilities, the CDC and batch, are existing in Qlik Talend Cloud, and we plug that into the Upsolver technology from the GA. Then obviously we include the Upsolver technology, that's with the adaptive Iceberg optimizer, and the ability to store data as Iceberg tables on S3, and publishing to the catalogs that were named before, the Glue catalog, Polaris, and the Snowflake Open catalog. So that's obviously a no data warehouse ingestion system and storing system. We have as well with that a mirroring to Snowflake, and I'll dig more into that. We have the ability to make this data available to Snowflake consumers for BI use cases typically. I'll dig more into that. And this will be AWS only at launch. We'll add more cloud providers later on.
So I have a question. How seamless will this be for customers who are on, like, for example, standard tier of QTC? How much of it is going to be like a faceless, it's all happening under the hood, and how much of it is going to be going through a wizard, and how much of it is going to be, I have to change my setup? What does GA actually mean from that perspective?
So in terms of the user experience, that will not change for users that's using QTC today. We have the storage capability and the project capability that's tied to a target platform, Snowflake, Databricks, and so on. We are basically adding another platform, which is the Qlik Open Lakehouse. So we'll start a new project that will work exactly as a Snowflake project, but on Iceberg. So in terms of roadmap, we will be adding streaming capabilities. So that's the Upsolver technology streaming into Iceberg that allows customers to ingest data at fast-paced and high data volume. It will be coming soon by the end of the year. As well, we want to support our customers who are using and running Qlik Replicate on-premise and Talend Cloud. So we'll work on bridges so that those customers can leverage the benefits of the Qlik Open Lakehouse. Data warehouse integration. So as I said, we have mirroring to Snowflake in the first version. We want to support mirroring in Databricks, Redshift, and others after that. More cloud provider supports, Azure first, so AWS at GA, Azure then, and then GCP. Streaming transformations and data quality expectations, those are the capabilities that Ori mentioned that allows us to do transformation on streaming data as data flows in and creating other Iceberg tables, other Iceberg objects that are the output of the transformations. So that's basically the three key capabilities of Upsolver that will be integrated in Qlik Talend Cloud. So now looking at a typical Qlik Talend Cloud project, so that's what our customers do today. So this is a screenshot of a pipeline in Qlik Talend Cloud. On the left, you have your data sources, and we have our CDC or batch ingestions that is loading data to what we call a landing area. That's the raw data. This is here to support the CDC process. We land the data raw as we replicate it, and then we take it to this bronze layer here. This is our storage task that takes care of doing the merges, takes care of making the data available for long term, and we typically create the type 1 and type 2 view. That's SCD, so type 1 is the current version of your data, type 2 is the historized version of your data to go back in time. Okay, and then you can have more layers, typically silver and gold layers. We have specialized tasks that allows you to transform data and make that fit for your downstream use cases. This is the type of project that you can create today with Snowflake, Databricks, Redshift, whatever. What we are launching in July is the ability to have your bronze layer, your storage layer with type 1, type 2 on Iceberg. Okay? So in terms of user experience, that's the same kind of project. It's just another target platform. What we want to do as well is we want to allow customers to store data on Iceberg, make that available through Iceberg catalogs, and as well to their data warehouse platform. They all use one or many data warehouse today. We want to keep that seamless for them. And for example, ability to mirror the Iceberg data to their Snowflake database. Okay, so I will show a demo that is a recorded demo. I've done that a couple of days ago, and I will comment on it live. So this demo will feature data ingestion from a SQL Server database into Iceberg data. This Iceberg data will be published to the AWS Glue catalog and consumed by the Athena query engine. Then we'll have a second part where we'll mirror the data to Snowflake and have transformation capabilities on Snowflake, showing you that you can consume and read Iceberg data from Snowflake. Okay, let's go. So opening one project here. So this is an example pipeline from the source on the left and going through the different tasks here to the right. This is a project that's created on the Qlik Open Lakehouse target. I'll open the settings. As you can see, platform type here. This is where you can have Databricks, Snowflake. We have the Open Lakehouse. We have configuration to Glue catalog and to S3. So we are replicating data here in CDC to S3 thanks to this what we call lake landing capability. So that's for storing the raw data and inserting all the changes as they are made in the source system. We insert that into S3 in this particular directory here. So that's S3. This is where we store data, raw data, with our landing capability. What's interesting then is the storage task. Storage task exists today. This is a storage task that runs on Iceberg. So we are replicating, taking care of these data sets here, as you can see on the left. And as part of the settings, we have as well the directory on S3 where we store data. So this is the other directory that I have here. And as you can see, these are all the tables that I'm replicating from the source. These tables are registered on AWS Glue in the Glue catalog under a database name and are available to any Iceberg-compatible query engine to query. So here I'm showing an example of a query using AWS Athena and querying the tables here. As I say, we'll support type 1 and type 2. These are views for the type 1 view. We are currently working on the type 2 that will be available for GA in the summer. We're querying type 1 version of the data through Athena or any Iceberg-compatible query engine. You can also see the physical objects, meaning the Iceberg tables, through our design UI. That's easy for designing and troubleshooting. You can view the data as well, Iceberg data, directly from the tool. Then I will show the mirroring to Snowflake. So we've added a new, the Lakehouse cluster. This runs with the Lakehouse cluster. We have a compute technology that comes from Upsolver that we deploy next to S3 on the customer infrastructure, and that's a number of nodes, and the cluster scales up and down based on demand and based on the data volumes that need to be ingested. You have scaling strategies as well that you can define if you want to control cost, or as opposed to that, if you want a lower latency. So jumping into that mirror task here. That's a new task that we've added to the product that allows to mirror Iceberg tables to another platform, here, Snowflake. So we have a configuration to Snowflake here and a set of settings so that Snowflake can access the S3 data, and Snowflake will connect to the Glue catalog as well. So what's interesting is that what we create on Snowflake. So we create this mirror task, creates a specific schema, and I'll show you these external tables, as they call that. So that's external table relative to Snowflake. So this is an Iceberg table here that's created on Snowflake using an external volume and a catalog that we manage with Qlik Open Lakehouse. And we issue refresh commands to Snowflake to make sure Snowflake always has the latest data and metadata. Then, since it's mirrored to Snowflake, I can create another project using Qlik Talend Cloud, which will be a Snowflake project in which I will consume these Iceberg tables. So this is a Snowflake project, as you can see here. This exists today. And as part of that, you can create a transform task that will take data and transform them. This transform task here is using Iceberg data from our Iceberg Open Lakehouse project as a source. As an example, it takes 2 data sets and transforms them using the transformation flow capability. This is very similar to the data flow capability that was shown before. This is for SQL pushdown. This is a version for SQL pushdown, and we generate SQL commands based on the visual transformation here. So you have 2 data sets, a join, an aggregate. We generate an output table that's translating to a SQL statement automatically for the user, and we push that down to the target platform, in this case, Snowflake. So this is the table that we've created. Actually, you can configure whether it's a view or a table. In this case, it's a view here. So every time you query this view, that will actually query the actual Iceberg tables, showing that on Snowflake to show you that the object is actually created on Snowflake. This is the view, and if you query it, we can provide the output. So that's it for the demo. So new capability as part of Qlik Talend Cloud, and as you've seen, not a lot of change in terms of user experience. That is all for us. So quick recap here. High volume data ingestion, hundreds of sources. All the sources that we support today with Qlik Talend Cloud will be ingestible into Iceberg. We'll add streaming sources as well very, very soon. Huge cost savings. You don't need a data warehouse to ingest data and store data for your bronze layer. And we have the Iceberg optimizer as well. All of that integrated with the Qlik Talend Cloud platform.